This is 3.4 equations of lines. So there is another equation of a line. We've already learned about slope-intercept form, where the name tells us what we're given. Slope-intercept form tells us we're given a slope, hey, that's m, and we're given an intercept, that's the y-intercept of b. Okay, so this new equation that we have is called point-slope form. And guess what? It's going to give us a point, and it's going to give us a slope. All right, so here's our form. Y minus y1 equals m times x minus x1. So m still stands for the slope. Okay, x and y without a 1 behind it, they stay x and y, just like we have a x and a y in this form. And then we have y1 and x1. Those stand for a point on this, what am I trying to say? On the line. They stand for a point on the line. So we know a point on the line and we know the slope of the line. And here we knew the y-intercept of the line and we knew the slope of the line. Okay, so if we are given a point and a slope, that's when we want to use this form. So for instance, down here, it says write the equation of this line in slope-intercept form. Okay, so we know we want it to look like y equals mx plus b. That's slope-intercept. And we know that this line passes through the point 2, -3 and has a slope of -2. So what were we given? Let's check what we were given here. A point and a slope. Since we're given a point and a slope, we're using point-slope form. So let's go ahead and plug that in. So we start with point-slope form. Let me write it out again. Remember, we don't substitute anything in for y or x. Okay, m we know is -2, so I'm going to put -2 in the m spot. And x1 and y1 stand for a point on the line. Doesn't matter what point, so I could use this point since it goes through the line. 2, -3. This is my x1 and my y1. So I'm going to go put 2 in the x1 spot, and I'm going to go put -3 in the y1 spot. Now, again, I want it to look like my end result should be in slope-intercept form. That means I need to get y by itself. I need to solve for y. So I'm going to get rid of these parentheses because slope-intercept form doesn't have parentheses. So I'm going to distribute my -2 to the x, and my -2 times -2 would be a +4. Y minus a -3, that's the same thing as y plus 3. So y still isn't by itself. I need to move the 3 over. So I'm going to subtract it here. And the 3 is like terms with the 4. So 4 minus 3 is a +1. This is slope-intercept form. Okay, so this line up here, we put it in point-slope form because we were given a point and a slope. And this is our ending form. It wanted it in slope-intercept form. If it would have said just put this in point-slope form, we would have been done at step 2. We plugged in the numbers, done. But it said it wanted it in slope-intercept form, so we had to solve for y. And we got y equals -2x plus 1. Let's look at the next one. It says write an equation of a line that passes through a point and has a slope. Now it doesn't say what form it wants it in. So we can write any equation of a line that goes through this point and goes through this slope. So the easiest thing to do is put it in point-slope form, which again is y minus y1 equals m times x minus x1. I want you to go ahead, plug in the point, plug in the slope, and tell me what you get for your equation of your line. Okay, you should have put 1 where y1 goes, so it should go y minus 1. You should put 1/2 where m goes, so equals 1/2, parentheses x minus, and then the x value of -1. You could have also have simplified the minus and negative to a plus sign. So x plus 4 would have worked. And I'm done. I don't have to solve for y here because I'm putting it in point slope form. If the problem would have said, write the equation of the line in slope-intercept form, then I would have had to solve for y, but it didn't tell me to do that. So I stopped here where it's easy. Okay, another form that we have is called two-point form. And one thing I want you to notice is this section right here in green. y2 minus y1 over x2 minus x1. That looks awfully familiar. And in fact, it's the formula to find slope. So what the heck? You're telling me that this green circle right here just stands for m, stands for the slope. So look at what form we have now. Y minus y1 equals m times x minus x1. Oh my gosh. It's the exact same as slope-intercept, or point slope, right? Point x1, y1, slope. This is point slope form in disguise. Why is it helpful? This is helpful when we're given 2 points. Okay, it's called two-point form for a reason. When we're given 2 points, we use it. So this right here, this just means you're finding the slope. Find the slope, plug it in for m into this equation. Okay, so don't let two-point form confuse you. So let's write the equation of the line that passes through points 4, 2 and -2, 3. Okay, so what am I given? This time I'm not given a slope. I'm given a point and a point. I'm given 2 points. And because I'm given 2 points, I want to use two-point form. So let's let this be my x1 and my y1. This can be my x2 and my y2. And let's substitute into our equation. So it goes y minus. Now remember, we don't sub anything for y. y1. So go and find y1, and it's a 2. y2 minus y1. So that would be 3 minus 2 over x2 minus x1. x2 is a -2. x1 is a 4. Parentheses. Nothing goes in for x. And then we subtract x1 to a 4. Okay, so all this fraction is doing is finding the slope. All right, so let's simplify. Y minus 2 over 1. -2 take away 4 is -6. And then x minus 4. Did it tell you what form it wanted it in? No, it just said write the equation. So I have a couple different options. I can write it in slope-intercept form, which is y equals mx plus b. I can write it in point slope form, which is y minus y1 equals mx minus x1. Which one is easier from here? Oh my gosh, the easiest thing to do would be put it in point slope form because it's already in point slope form. Why would I solve for y when it doesn't tell me that I need to? Don't always be trying to solve this for y. Only if it says put it in slope-intercept form, that's when you solve for y. I can leave my final answer like this. It just said write an equation of this line that goes through these 2 points. Well, this equation is that line, so I can stop. Okay, write the equation of this line. What are we given? A point and a point. That means we're using two-point form. So I'll write it for you here. And then I want you to solve this for me. And you can leave it in point slope form so you don't have to solve for y. Okay, go ahead. Okay, I hope you didn't have to, but I hope that you labeled one of these your x1, y1, and one your x2, y2. That way, when you plugged it in, it was easier to go off of. So here's what you would have gotten, or here's what you would have plugged in if you let this be your first ordered pair and this be your second ordered pair. So if you simplify the slope of this, 6 minus 4 is 2, and 5 minus 1 is 4. Okay, so y minus 4 equals 2 over 4 x minus 1. Well, I just simplified 2 over 4 to be 1/2, and I can stop there. Let me show you what you'd get if you let this be your x2 and y2, and this be your x1 and y1. It's not that you're wrong, it's not wrong at all. There could be multiple equations or multiple forms for these same line. Okay, so this green would be correct also. All right, so it's still the same slope, yes, because it's the same exact line. It should have the same rise over run, but now it's saying it goes through 5 and 6, the point 5 and 6. Over here it said it was going through the point 1 and 4. Okay, so same lines, you could have either answer, and I would have counted it correct. Let's look at other equations of lines. Horizontal lines we know have a slope of 0. Okay, they're flat, side to side. And we have a formula for, not formula, we have an equation for horizontal lines, and it's y equals b. Remember what b stands for. B stands for the y-intercept. It's where it's crossing the y-axis. So let's just make this graph like 1, 2, 3, 4, 5. Okay, so this would be the point 0, 5. That means the b here is 5, right? It crosses the y-axis at 5. So the equation of this line is not going to look anything fancy like y minus 4 equals 1/2 x. Yeah, it's just going to be y equals 5, whatever number it crosses the y-axis. So this is telling you what axis it crosses, and this is telling you where. Okay, so if we keep that in mind, then we have this same idea, but for vertical lines. Vertical lines we know have an undefined slope. They go up and down. They're going to be of the form x equals a. A stands for, just like B stood for where it crosses the y-axis, A is the x-intercept. Okay, so if I gave this a number, this would be the point 5, 0, right? And A here would be 5. So this form, x equals a number, same thing. It's telling you which axis it's crossing and where it's crossing that axis. This is crossing the x-axis at 5, which means it has to be a vertical line. If it's only crossing the x-axis, it's never going to be side to side or diagonal, up and down. We want it parallel with this y, because parallel lines we know will never intersect. Just like horizontal, if it's crossing the y-axis at 5, that means it can't ever touch the x. It's only touching y at 5. Okay, so it needs to be parallel with the x-axis. So horizontal lines, y equals, vertical lines, x equals. Let's write an equation for each line. So here's a clue. It's a vertical line, and it goes through the point -2, 4. It's a vertical line. That means if you picture a little mini coordinate plane here, and it goes through the point -2, 4, that's somewhere up here, vertical line. Which axis is it crossing? It's crossing the x-axis. And where is it crossing the x? At -2. That's the equation of this vertical line. Horizontal line. Horizontal line. So if you want to picture a mini x and y axis, this is a horizontal line that goes through 0, 6. So somewhere up here at 6, it's horizontal. Which axis is it crossing? Crossing the y. At what number? 6. That's the equation for a horizontal line. Okay, what about graph over here, number E? So it's a horizontal line, and if you don't remember if that's y equals or x equals, look at which axis it's crossing. It's intersecting the y. So it's y equals, and at what number is it intersecting the y? -2. Okay, try F for me. Hopefully you found out that it crosses the x-axis, so it's x equals, and then it crosses at -2. If you didn't follow that rule of which axis it crosses, a vertical line, if you go back and look at your rule here, a vertical line has a form x equals a number, so that number is wherever it crosses. All right, let's try C and D. A line that goes through the points -2, 3, and 3, 3. We're trying to figure out the equation of this line. So you can either think about a little mini coordinate grid here, and -2, 3 would be somewhere over here, and 3, 3 would be somewhere over here. So this looks like it's going to be a horizontal line. If you didn't want to sketch a picture, the other thing you could do is find the slope between these 2 points. And if you found the slope, you'd get 0/5, and you know the slope is 0. Well, a 0 slope, it's 0 fun to ski on a flat horizontal mountain, right? Okay, so it's a horizontal line. We established that. So what's the equation of a horizontal line? Well, it's going to cross the y-axis. And at what number is this crossing the y? Look at the y's here. They're both 3, so it crosses at 3. All right. The easiest thing I would suggest for you to do is sketch a picture. Okay, go ahead and try part D. Okay, if you were to sketch a picture, -1, 2 and -1, 3 form a vertical line. If you were to check the slope of this line, you would get 1/0, which means undefined. There's an undefined slope, so you know that's a vertical line. So it crosses the x-axis, has the form x equals a number. That number is where does it cross? And both x's here are -1. So x equals -1 is the form of this line. All right, last thing that we're going to talk about is parallel and perpendicular lines. All right, remember that parallel lines will have the same slope. Perpendicular lines will have opposite reciprocal, right? Negative, positive, and then flipped. So we want to write the equations that pass through the point 3, -2, and part A is parallel to this line. Okay, so if this line, okay, so this red line here is on a graph somewhere. I don't know what it is. Let's call it, or actually let's make it yellow. Okay, I don't know, I'm just gonna say that's the yellow line. Okay, so we need a line that's parallel to this yellow line. However, it has to go through this point 3, -2. Okay, so let's say it goes through the point 3, -2 and is parallel. That'd be the blue line. Okay, so we're writing the equation of this blue line. We know the equation of the yellow line. We just need the blue line to be parallel. Okay, because the point 3, -2 is, let's just say, somewhere over here. All right, there's a lot of lines that go through that point, but we want the equation of the one that's parallel with the yellow. Okay, that's our end goal here. That's what we're trying to do. So I have this equation of the yellow line, but I don't really know its slope. Remember, if I'm going to have parallel lines, I need to know the slope so I can make it the same. So what I'm going to do is I'm going to take this line, x minus 4y equals 6, and I'm going to put it in a form where I can easily see the slope. So I'm going to put it in slope-intercept form. That way I can see which number is the slope, right? Y equals mx plus b form. I want to know what m is. In order to put it in this form, I need to get y by itself. Okay, so let me change to green here. so that it's easier to see. Mx plus b. I need to get the m. So I'm going to first put it in slope-intercept form. Okay, I need to get y by itself, so I'm going to get rid of the x. It's a positive x. I'm going to subtract it. The x's will cancel. Drop down my negative 4y. And these are not like terms, so I have a negative x and a positive 6. Next thing, to get rid of the times by negative 4, I'm going to divide by negative 4. And when I multiply or divide, I have to do it by everything. So my negative 4's will 1 out, and I'm left with 1y. A negative divided by a negative would be a positive. 1x over 4, or 1/4 x would work. And then a positive divided by a negative would be a negative. 6 over 4, I could leave it as 6 over 4, or I could simplify it to 3/2. Okay, so I put it in slope-intercept form. That way I could figure out what the slope is. The slope is the number with the x. So I've just found out that my slope, my m to this yellow line, is 1/4. Okay. All right. Now that I know the slope, I know how to make a line parallel. Right? If I'm going to have the equation of this blue line, it needs to have this slope. So here's what we got. We've got a slope and we've got a point that it goes through. Which form are we using? If we have a point and a slope, we're using point slope form. Point slope form. So I'm plugging in for y1 here is my negative 2. M has to be 1/4. X I don't change, but x1 I'm going to plug in 3. All right, now I just want to simplify one thing because it doesn't say to which form I need to write my equation. I can leave it in this form, but I do want to change a minus a negative to plus a positive. So y plus 2. Okay, so this is the equation of the blue line. This is the blue line that's parallel to this other yellow line. Notice how I have two equations here. They're different lines. Okay, two different lines, but they have the same slope, which means they're parallel. All right, let's try perpendicular now. Notice how it says we want it now perpendicular to this line. Well, it's that same yellow line. I'm going to change it to green. It's that same green line as in part A. We're still going through this point. Okay, so let me paint you a little picture here. I have a green line somewhere. And I have the point 3, negative 2 over here. This blue line was parallel with it. Now I need a line that goes through this point, but it's perpendicular to my green line here. Okay, so it says it wants it perpendicular to the green line, but it's got to go through that point. Okay, well, I already took this green line and I put it into slope-intercept form. Remember, it was, let me change to green. It was y equals 1/4 x minus 6 over 4. I know the slope of this line is 1/4. So what would a slope perpendicular to it have to be? Well, a perpendicular slope to 1/4, since 1/4 is positive, it's got to be opposite, so I'm going to make it negative. And then it's got to be flipped, so 4 over 1. In other words, 4. Okay, so when I go to this red line, it's got to have this slope, right? Because the slope here was 1/4. Now this red line's got to be negative 4. All right, in the blue line, we wanted it to be 1/4 because they're parallel. They got to have the same slope. So let's go back to our point here. 3, negative 2, and we got a point and we got a slope. Remember, a point and a slope, we're using point slope form. But instead of plugging in 1/4 for m, now we're plugging in this perpendicular slope of -4. x1 is still 3 because I'm still going through that same point. And y1 is still -2. So instead of writing minus a -2, I'm going to write y plus 2. Y minus a -2 turn to y plus 2. So I have the equation of this red line, the equation of this blue line, and I was given the green line. Okay, the red and the blue both went through that point. Blue line's parallel, red line's perpendicular with the green line. And I think what I'll do is instead of going over these examples now, we'll do them in class tomorrow.